This is the Burj Khalifa. It's the tallest building in the world. It has 163 floors, and it's twice as tall as the Empire State Building, and 3 times taller than the Eiffel Tower. The total weight of the concrete for the building's foundation is 110,000 tons. That's like 2,200 Boeing 737s, or 50,000 SUVs, or 69,000 hippos. It took 22 million human hours to build. That means that if you were to build Burj Khalifa by yourself, it would take you about 2,500 years to do it. And now, imagine that huge thing slowly sinking into the sand until even its spire is underground. Skyscrapers are usually built on solid ground. Take a skyscraper in New York and dig a little deeper under it. There's always some kind of rock foundation to support the weight of the building. But if you dig a hole in Dubai, you'll only find sand. In theory, the whole city should have sunk in the sand, but it's still there. The main reason the Burj Khalifa stands firm is that the sand for the building's foundation was brought from Australia. Wait, but Dubai is built in a desert. There are billions of tons of sand there. Well, that's right, but the problem is its shape. There are lots of dust storms there. The wind picks up sand grains. They rub against one another, get polished, and gradually turn into microscopic balls. This makes the sand doughy, almost like snow. And if you squeeze a handful of such sand, there will be a lot of air between these balls. That's because they don't cling to one another tightly. But usually, sand grains are shaped like diamonds. If you squeeze such sand in your hand, the grains will press against one another like puzzle pieces. This way, they can withstand intense pressure. So, engineers imported millions of tons of sand to Dubai to create a strong base for the foundation of the building. The second thing about this type of sand is friction. The less smooth it is, the harder it is for you to slide on it. The building will literally cling to the sand with its foundation. Now, let's sneak a peek underneath the Burj Khalifa. First, the engineers drilled 192 holes, each about 164 feet deep. That's 3 times the length of a New York City subway car. Then, these holes were filled with concrete and about 39,000 tons of steel rebars to reinforce the structure. These are called piles. Concrete resists compression well enough, but it doesn't fare well when it gets twisted or bent. Luckily, steel rebars are great at dampening those forces. The sand around the piles is tight against the concrete. The friction between the sand and the piles keeps them from falling deeper. It's like sticking your hand in the sand at the beach. It can easily go down a dozen inches, but then the friction will stop it. When the piles were ready, it was time to create the base of the building, something like a concrete pillow. It's shaped like a flower with 3 petals, but this is not only for beauty, it's also for reliability. When you step on doughy snow with your feet, you fall all the way down to more solid ground. But if you wear snowshoes, you can walk on the snow surface. This is because your weight is distributed over the snowshoe area. The shape of the base of the Burj Khalifa has the same function. It distributes the construction's weight evenly, so that the building doesn't sink into the sand. When the base was ready, workers began constructing the building itself. Whoa, it really swings a bit. Don't worry, it's done on purpose so that the skyscraper doesn't collapse. If you make the construction too stiff and don't let it swing, at one point, a strong gust of wind can just break it at the very base, and it will fall. So all skyscrapers are made a bit flexible. When the wind blows, the skyscraper tilts a little. This puts a lot of force on one side of the building's foundation. But concrete tends to shrink slightly, which dampens that force. Then the concrete decompresses and returns back to normal. When the wind is especially strong, the spire of the Burj Khalifa can sway 6.5 feet. The architects have come up with an even crazier idea for Dubai: a spinning building. It'll be an ordinary skyscraper, but each floor will rotate 360 degrees. Engineers are planning to install a rigid rod inside the skyscraper. It'll hold the entire weight of the construction on itself. Then each floor of the building will be attached to that rod, and the inhabitants of each floor will be able to choose the direction and speed of rotation. So, building on sand is actually quite reliable and simple. It was much harder to build skyscrapers in Manhattan. There's hard rock that can support a skyscraper there, but it lies 10 stories deep underground. So, engineers came up with a solution. These are wells. First, a concrete ring is placed on the ground. Workers start digging a hole right underneath it. They remove soft soil, and the concrete ring begins to sink under its own weight. The builders then put another ring on top of it and continue digging. One by one, the rings go lower and lower. A small crane helps to lift the soil to the surface. It's essentially a vertical tunnel that leads to nowhere. When the well reaches the rock hidden underneath the soil, the builders climb back to the top. The well is then filled with concrete. It looks like a giant pile. A dozen of these powerful piles can support a large skyscraper. But it's much harder to create a building foundation in a seismically active zone. That means a place where earthquakes frequently happen. The method of protection against them is simple. Like with high winds, you need to make the building flexible. Let's look at the foundation of such a construction. Good old piles hold the enormous weight of the skyscraper, but the concrete pad of the building itself stands on huge springs. During an earthquake, the ground shakes and moves from side to side, but the springs dampen and compensate for the movement, so the building stays in place. Also, engineers surround buildings in earthquake zones with concrete circles underground. So, here's a skyscraper with its foundation. Here's one ring around it, and here's another. When an earthquake hits and the ground starts to shake, these rings dampen the force of the earthquake. And if around the rings it feels like strong waves, inside the perimeter, it's like a calm bay. Another option is to reinforce the building with steel beams. You may have seen these things on bridge piers, but in this case, there are small cylinders on each beam. Each cylinder is filled with oil and has a piston. When the building starts to swing during an earthquake, the piston starts to compress the oil in the cylinder. The oil turns the mechanical energy from the swinging into heat. This dampens the energy released by the earthquake. And sometimes, engineers have to construct a building in a place where there's a lot of water in the soil. If you drill a hole for a pile there and fill it with concrete, the water will wash out the cement or keep it from drying out. In such cases, you have to freeze that water. To do it, builders make a lot of small drill holes at the construction site. Then they put pipes into these holes and create a connected pipe system. There's a similar pipe system in your fridge. It's hidden under the inner paneling. Now, we pump some liquid nitrogen inside. The water gives off its heat to the liquid nitrogen and starts to freeze. Meanwhile, the workers have time to fill the pile holes with concrete. But water in its ice form takes up more space than in liquid form. So when the ice melts, the ground sags a little. So what if you want to build a city on water, like Venice? Then you'll need long piles. The builders of Venice used wooden ones. They had to get to the bottom of the lagoon first, and then they moved a few more dozen feet deeper through the soft clay soil until they reached the hard rock. The builders drove such piles around the perimeter of the future building, and the construction itself was built in such a way that most of its weight rested on the outer walls. If you dive underwater in Venice, you'll see hundreds of thousands of such piles. The task is more difficult if you build a bridge. In addition to a solid foundation, you have to take into account thermal expansion. The rule is simple. When something gets hot, it expands, and when it cools, it shrinks. Look at railroads. There is a gap between each rail. The clatter of the wheels you hear when on a train is born exactly on these gaps. When the sun heats the rails in the summer, they extend. This creates tension inside the metal. Then the rail can bend sideways or even upward, like a worm. But if engineers have provided such gaps, the metal will expand and fill that space. A bridge is exactly the same as a huge rail, and in hot weather, it can expand too. So engineers leave gaps there on purpose. You can see them on the surface of the bridge. They're usually covered with a sheet of metal that looks like a comb. When the bridge heats up, these combs come together.
Most of Europe's skyscrapers are concentrated in 5 cities. Those are London, Frankfurt, Paris, Moscow, and Istanbul. But even combined, all these places have fewer skyscrapers than New York City alone. For a building to be considered a modern skyscraper, it has to be about 490 feet high, which means it should have at least 40 to 50 stories. A story is simply one floor of a building with an average of 14 feet from floor to ceiling. If you had visited the U.S. just before the 1870s, you'd have found only one skyscraper. The home insurance business in Chicago was the world's first high-rise building with 10 floors. Wow! In Europe, the first skyscrapers appeared in Moscow. They were called the Seven Sisters, but they were built only in the mid-1900s. North America started to construct more and more high-rise buildings. It happened because cities were getting too populated. Every piece of land was too valuable. New York's Skyline is so famous you'd probably recognize it even if you've never been to this city before. It's the same for Paris. But could you imagine the Eiffel Tower surrounded or even blocked by skyscrapers? It would surely lose some of its magic. La Défense district is where you'll find skyscrapers in Paris. This way, they don't interfere with the romantic and touristic scenery of the city. In London, things are done a bit differently. Some of its skyscrapers have unusual shapes. One of such constructions is the Gherkin. If you get stuck in this building, you'd really be in a pickle. Another interestingly shaped skyscraper is the Shard. There's one more nicknamed the Cheese Grater. These are not their official names, of course, but they do make sense if you look at the shape of these buildings. But it's not some random architectural concept. The reason the skyscrapers are shaped like this is not to obscure St. Paul's Cathedral. By the way, the top of this monumental construction is visible even from King Henry VIII's mound, and that's a great distance away. Anyway, there are also other sites, like the Tower of London and the Palace of Westminster. They have their own viewpoints. So, not to ruin London's skyline, it's not allowed to build anything that would block these monuments. Most European cities already existed when the US started to build its first skyscrapers. That's why they didn't have much space to fit in giant buildings. Evenly zoned cities were the result of their steady growth throughout the years. For example, in Lisbon, there's a viewpoint in Eduardo VII Park. From that point, you can see all the park and the river. If suddenly there was a bunch of 490-foot-tall buildings standing around, this gorgeous view would be totally ruined. You wouldn't see the iconic avenue, and forget the river. Instead, there are buildings. Like Lisbon, many other cities in Europe don't want skyscrapers to spoil their cultural heritage. Take Germany. Most of their skyscrapers are in Frankfurt. In other cities, they'd rather protect and restore the buildings that are already standing. And even if, let's say, Berlin wanted to home some skyscrapers, it wouldn't be able to do it in any case. Its soil just wouldn't allow it. Put a skyscraper there and it'll sink. Constructing a foundation for a very tall building in Berlin would mean investing a lot of money. The soil's too sandy and soft. But what if you ignored all the cultural heritage and still decided to fill a European city like Prague with skyscrapers? First, you'd have to demolish a lot of what already exists there. This would lead to an angry crowd of people complaining that the city they know and love is gone. Brussels has experienced this to a certain extent. There's even a term for this phenomenon: Brusselization. Simply put, it means not caring where you place new high-rise buildings. Here is fine. Oh, sprout one over there too. Hey, we could call them Brussels sprouts. Or not. But in most cases, city authorities don't want new constructions to change the historical appearance of the place. Some large European cities might even follow France's example and choose a separate district, a place just for skyscrapers. The Burj Khalifa, which is more than 2,700 feet high, is the tallest building in the world. It wasn't an easy feat to construct it. The skyscraper took 6 years to build, and folks say it was worth the effort. The construction is so tall, you can see it from 60 miles away on a clear day. The tallest building in Europe is only half that size. The Lotte Center in St. Petersburg is a bit more than 1,500 feet tall. Well, the question is, if skyscrapers are so tall, why don't they get knocked over by wind? Their structure, from the very foundation to the highest point of the building, is the answer. Take the Burj Khalifa, please. The soil where the skyscraper is built isn't ideal. So, beneath the 110,000-ton concrete foundation of this massive construction, there are 192 piles driven to a depth of more than 160 feet. Thanks to the friction between the concrete and soil, these piles don't move at all, creating a solid foundation. But most skyscrapers are built on bedrock because it barely shifts. Their frames are made of steel. If you looked at a skyscraper without its external structure, all you'd see would be a bunch of steel beams. The taller the building, the more the winds affect it. Taming them is one of the biggest challenges skyscrapers have to tackle. Imagine you're on one of the top floors of a skyscraper. Suddenly, a strong gust of wind hits the building. The entire construction starts wobbling, and you can feel it even inside. You might even get knocked over if you don't grab onto something. To avoid such a situation, most skyscrapers have a pendulum-like structure inside. It absorbs some of the wind's force. This thing is called a tuned mass damper. The mechanism acts as a counterweight. When the skyscraper gets hit by the wind, it's the tuned mass damper that moves instead of the building. Some high-rise constructions don't need this pendulum. The Shard, for example, deals with the wind with the help of its tapered shape, and Shanghai Tower uses its 120-degree twist. Both skyscrapers have incredibly smart structures. That's why they don't get too wobbly when the wind hits them. The Shard doesn't have a tuned mass damper whatsoever, and the one in Shanghai Tower only serves as a tourist attraction. Before a building's design is finalized, it normally undergoes a wind tunnel test. A model city is built and tested with this new super tall addition. When the experts turn the wind on, it simulates real-life conditions. Let's say the model skyscraper breaks under the wind's pressure during the test. Then the chances are it's going to tumble over in real life, too. Winds up there can be so strong that things like wind turbines have become a thing. The Bahrain World Center has 3 of them right in the middle of the building. But there are some others. Strata SE1, for example, has wind turbines at the top. There's a phenomenon called the downdraft effect. It's accelerated winds near the skyscraper. When a powerful gust of wind hits a high-rise building, it gets pushed upward around the sides of the construction and down toward the street. That's why if you're passing by a particularly tall building on a windy day, you might have to force your way around. But let's say several square-cornered skyscrapers are built next to each other. Then they're likely to channel the wind through the streets. This can create many hurricanes on especially windy days. A study once examined 100 tallest buildings that were about to be dismantled by their owners. It turned out most of them had an average lifespan of a mere 42 years, but some of them can last much longer. For example, the Temple Court building is still standing to this day. At 150 feet, it's a bit smaller than others, but it's already seen 100 winters throughout its life. Now, the first thing that comes to mind when you think of getting rid of a building is dust, debris, and deafening noise. But things aren't quite as dramatic as that for most skyscrapers. When you want it gone, you take it apart, bit by bit. This process starts from the top and goes all the way down to the bottom. Voila! The building is slowly disappearing in front of your eyes. Abracadabra. Ah, the Big Apple at night. New York, New York, the city that never sleeps. How can they? There are way too many lights. But I want to talk about these ones, the red ones. Here's what they look like if you come closer. These red lights are a must, and they're called aircraft warning lights. They're mounted on the top corners of tall buildings to ensure there's no risk that an aircraft will collide with them. The lights are visible for miles around the structure and will signal the passing aircraft that there's a building that they should avoid. Please. The lighting standards are set by the International Civil Aviation Organization and are adopted worldwide. Now they require that all obstacles 148 feet above ground level and taller are marked with warning lights. In close proximity to an airport, even lower buildings can be illuminated too. So, any building, towers, electricity pylons, and chimneys will have these lights for safety. The number of lights and light levels depend on the width and length of the structure. There are also different types of buildings. Some should be lit only at night, some both during the day and night. They can use red or white lights. For buildings that should only be lit at night with red lights, there must be lights at the 148-foot level. Taller buildings should also have lights at the 345-foot level and at 690 feet. Buildings that must be lit both during the day and night with white lights have them with 345, 690, and 1,033 feet. The first skyscraper in the world is the Home Insurance Building located in Chicago. It was built back in 1885. It was a special building constructed using a new method. Buildings used to be supported by masonry walls, which couldn't be very tall because they would be too heavy. The Home Insurance Building had a revolutionary design that allowed it to be higher than other structures. It had an inner skeleton made of steel. The walls around it could be way thinner than usual, and the whole structure could be higher. The Home Insurance Building was a 10-story one, standing at 138 feet tall. Today, it wouldn't even require any aircraft warning lights because it's not even considered that tall. Still, the building started the new construction era. It stood strong until 1931, when, together with several other buildings around it, they took it down to construct something new, the field building that Chicago has now. In 1931, the year the home insurance building was demolished, the Empire State Building was finished. It is 1,250 feet tall, like 10 home insurance buildings on top of one another. That's the construction progress humanity achieved in just 46 years. The Empire State Building became the tallest one in the world. Now, long surpassed, it's the skyscraper that held the record for the longest time, for 39 years to be exact. In 1970, the World Trade Center became the highest one, although it was just 100 feet taller. Now, a bit more than a half a century later, the Empire State Building is ranked 53rd on the list of the tallest buildings. Humanity climbed way higher. Now, the world champ is Burj Khalifa, located in Dubai in the United Arab Emirates. The building was finished in 2010. It's 2,717 feet tall, more than 2 Empire State Buildings on top of one another. Skyscrapers are often made of glass for several reasons. First of all, they can press glass in every shape possible. So, the skyscraper can no longer just be a plain boring tower as before. They can design it in any fancy shape as they do around the world. Second, the glass is thin. There's no need for thicker walls like pre-home insurance building times. The walls are thinner, and the floors are bigger, providing more inner space. Glass is also pretty light and allows to make the building very high. Transparent glass reduces the need for electrical lighting inside the building, so it's also very cost-effective. Even more, glass is temperature and weather resistant. And finally, it just looks posh, fancy, and modern. Compare this and that. The latter definitely looks more futuristic and cutting edge. Skyscrapers started out in the United States, but became very popular in Asia, which now has over 7,500 skyscrapers. A skyscraper is now a construction that is 492 feet tall and higher. 9 out of 10 tallest buildings in the world are located in Asia. The country with the most skyscrapers is China, with more than 3,000 of them. Asia has the largest population in the world, and its economy is booming. So, growing high happened to be a perfect solution to fit the most people in its cities. The second most skyscraper-populated continent is North America, with more than 1,000 skyscrapers. New York alone has more skyscrapers than all of Europe combined. And here comes my next question. Why doesn't Europe build skyscrapers? There are just 250 of them there, and half of them are located in just 3 cities: Moscow in Russia, Istanbul in Turkey, and London, the UK. Let's go back to the beginning, and that is the end of the 19th century when skyscrapers' history starts. The first skyscrapers were built in the United States. As an independent country, the United States of America was just 1 century old back then. They built cities from scratch. There was a lot of available land. People could build a house here, and also over there. By that time, Europe had been growing for a while already. The history of Paris dates back to 259 BCE. It wasn't 1 century old, but 20 centuries old. German Cologne was founded in 38 BCE. Rome, Italy's capital city, dates back to 753 BCE, so it was 26 centuries old back then. By the end of the 19th century, Europe had been pretty much built. There was not much extra room for construction, and no one wanted to take down the Colosseum and put up some fancy skyscraper instead. This is history, and Europe likes to preserve history. There was no practical reason for changing things. The driving force of Asian and American skyscrapers was the booming city population, and especially rapid urban development of city centers. As people were moving to the city from the suburbs, they needed more floors to accommodate more people on a limited territory. In Europe, despite the population growth and city migration, there was still enough room for everyone. The Europeans are very protective of their city skylines. One interesting story of Brusselization takes us to Brussels, the capital of Belgium. In the 1960s, there were no zoning regulations, and some buildings in Brussels were demolished to make room for more modern ones to develop business districts. Uncontrollable construction started, and modern buildings were built in random places around Brussels. They had no cultural or historical value, and they didn't fit in the city's architecture at all. messing up the city's image. Many architects and other people protested, and new laws were introduced, restricting the demolition of buildings of historical importance and taking construction under control. Other European countries learned from Belgium's mistakes. People across Europe still dislike modern structures. Many cities adopted zoning regulations, and building a fancy glass skyscraper in Europe isn't that easy. Still, cities with big financial centers, like London, Moscow, Frankfurt, or Istanbul, require commercial space. So, in some cities, there are several skyscrapers somewhere outside the historic center, forming separate skyscraper districts. And then there's Rome. It rejects any skyscrapers completely, stating there will never be a high-rise there. Some other Italian cities follow in its footsteps, willing to preserve their historical image. But there's more to it. It's not just people and cultural preservation. Building a skyscraper in Europe isn't as easy as in North America for engineering reasons as well. For example, Berlin, the capital of Germany, is built on muddy ground going down about 260 feet. That's the height of a 20-story building. Without firm ground, a tall building can't stand on the surface safely. Hey, ever played Jenga? Yep, it's kind of the same, only in real life. Building something really tall requires a lot of groundwork. Plus, it can be risky. That's another reason for the lack of skyscrapers, in addition to the attempts to preserve history. And now, let's play. I'll show you several city skylines, and your task is to guess which city it is. Off we go. Here's the first one. Very easy. What do you say? Of course, this is New York. How about this one? It's Hong Kong, China. This is the city with the largest number of skyscrapers in the world. It has 517 skyscrapers, twice more than all of Europe. Okay, let's move on. What city is this? This is Dubai, the United Arab Emirates. By the way, this is what the city looked like in 1990, before they found oil. Yep, it's the same city, and yes, it's just a 30-year difference. Can you recognize this one? It's good old Chicago, the Toddlin' town. What's next? It's Frankfurt, Germany. Okay, a couple more. You can make it. That's Istanbul, Turkey. And the last one for you, it's easier. I'm sure you'll recognize it. Yes, that's Melbourne, Australia. G'day, mate.